Hey guys, welcome to day 59. Today we're just going to continue with our rate in, rate out, looking at a couple more questions they might ask here. They could ask lots of different questions about this scenario. I'm trying to get you prepared for the most common ones, but they could ask a question out of left field and you just have to do your best to take what you know and figure it out from there. Okay, so we're continuing with the same prompt as before. So if we just go up and get familiar with it, you might want to replug this into your calculator. We have this set up here from our day 58. We have R of t, which is our rate in. That's in my calculator as Y1. That's between the hours of 0 and 8. We have our rate out, which is 5 liters per hour. Right, a constant rate out. That's in as my Y2. And that starts at 2 and finishes at 8. We have our initial condition of at t equals 0, the tank has 60 liters of water. And if you remember, we wrote this. It's going to be very important to be able to write an amount in tank equation for any time t. If you notice, it's 60 plus our initial condition plus the integral of the rate in minus the integral of the rate out. Notice the rate in integral starts at 0, right, and goes to t. The rate out in this problem happened to start at 2. Sometimes it'll have a different start time for the rate out, sometimes it won't. Okay, so let me just show you a couple more questions that they could ask you. Okay, so here's another question that might be asked. Okay, so here's the setup. It says find R prime of 3, including units, interpret the meaning of R prime of 3 in the context of the problem. Okay, one part of this is going to be very easy. Finding R prime of 3, right, especially with our calculator, will not be difficult. But the including units and interpreting the meaning of it is oftentimes much more difficult for people to do. So first off, let's talk about finding R prime of 3. First off, R of t is listed as my Y1 in my calculator. And obviously this problem is about doing the derivative of R. So let's go back to our graph. As we can see here, my Y1, this blue line, is R of t. And I want to find the derivative, right? I know that because the prime means derivative. I want to do the derivative at time 3. I'm going to do second calc. Number 6 is for my derivative. So I'll select that. And then I'm going to choose at time 3 to do that derivative. And I get 1.321. So I'm going to say R prime of 3 equals 1.321. Now interpreting the unit here, right? R is already in liters per hour, but I'm doing another rate of change of that. So it'll be liters per hour squared. So let's go back and do 1.321. And again, that'll be in liters per hour squared because it's another rate of change. Okay? So interpreting the meaning of this, okay, here's what I'm going to say. Since I notice that this is a positive number, okay, I'm going to talk about this as, right, R is the rate that water fills the tub. R prime then would be the rate at which the rate of water filling the tub is changing, right? It's a rate of change of a rate of change. Now that sounds kind of weird to say, so I often say it like this. And I'm going to start by describing R And then I'm going to talk about what doing the derivative means, right? Since r prime is positive, that means r is increasing. So here's how I'm going to say this. The rate at which water fills the tub is increasing. So, talking about the rate at which water fills the tub is talking about R. Okay. Now, the fact that I'm saying is increasing, that's because R prime ended up being positive, is increasing at 1.321 liters per hour squared. At, and I have to specifically mention what the 3 means, at t equals 3 hours. You don't like saying it that way, you could say the rate of change of the rate at which water is filling the tub, right? The rate of change, talking about prime. Rate at which water fills the tub talks about R. You could say the rate of change of the rate of water entering the tub is 1.321 liters per hour squared at t equals 3 hours. Okay, let's talk about question E, another possible question they could ask. Okay, so here's the question. What is the max amount of water in the tub on the interval 0 to 8? Okay, so when they're asking about the, right, this is a question about an absolute max. What we have to learn, or what we have to understand here, is absolute maxes and absolute mins can only occur at 2 different places, critical points and endpoints. So, and it's asking about the amount of water in the tub. Well, we already have an equation for the amount of water in the tub. Just as a reminder, that equation is A of t equals 60 plus integral 0 to t of r of t dt minus integral 2 to t of 5 dt. Okay. So that is our amount of water in the tub equation. Okay. So what I need to do then, right, to justify this, I just have to check all the endpoints and critical points. So here's what I know. I know I need to check time 0 and time 8. Okay. But I also need to find any critical points. And a reminder, a critical point is when the derivative equals 0. So let's think about a prime here really quick. A critical point is when the derivative equals 0. Right? When I go ahead and do the derivative of this equation, I already did it earlier, but just as a reminder here, the derivative of 60 is 0. The derivative of the integral of r of t is simply r of t. The derivative of the integral of 5 is simply 5. So what I want to do is set this thing equal to this derivative equal to 0. So basically, I just need to figure out when does r of t, right, solving this equation, I can add 5 to both sides. I need to figure out when r of t equals 5. And that's going to be a critical point that I need to test. Well, if we look back at our graph, It's pretty easy to think about where R of t equals 5, because I have R of t graphed and I have 5 graphed. And they're going to equal each other right out here at this intersection. Okay, it should also make sense to check this, because from time 0 all the way to this time, the tub is filling at a rate greater than it's draining. But that switches at that time. So I'm guessing my maximum value is going to occur here, but I'm just going to have to test it. Okay, now to figure out that intersection point, here's what I need to do. I'm going to do second calc, number 5, intersect. I'll just arrow close enough to that so it'll read it. Let's begin. Enter, enter. And I get that time right there. Now, here's what we need to understand. That time, right, I want to write all those decimals down. I'm going to have to plug that time into my equation, but I need to use all of my decimals towards my final answer. So I'm just going to write it on my whiteboard next to me here, 7.1354112. Now, to make life easy, I'm going to have my calculator store this for me. So here's what I'm going to do. I'm going to hit, it'll always store your x value if you want, right? If I just quit and I type in my store, it'll store my answer as, I'm going to use the letter B. I don't want to use A because my equation is already about A. And you notice that same number pops up here. So now I have this stored as B on my calculator. Okay, but if I'm going to store that on my calculator and I'm going to write an equation with that, the grader needs to know it. So here's what I'm going to say. R of t equals 5 when t equals, and I'm going to write 7.1354112, and I'm just going to tell the grader that I'm going to let that equal the letter B. So I don't have to keep writing 7.1354112. Okay? So I need to test time B. Right? Now I can use B the rest of the time because the grader knows, hey, when I'm talking about B, I'm actually talking about that point when R of t equaled 5. Okay? Now I just have to go and plug everything in to my amount and figure out which one makes the biggest. Well, the nice thing is I've already done a lot of this work. I know that A of 0 is 60. So that's my initial condition. That was straight up given to me. A of 8, I already asked you that question back up here, so we don't need to solve it again. Let me just find A of 8 really quick. Hopefully really quick. How much water? See, I already answered that question, and it's 89.620. So I'm going to go ahead and put that in down here, 89.620. Okay. Well, what I need to figure out, what I haven't done yet, is the amount of water in the tank at time B. So I'll write that out. I know that A of B would have to be 60 plus the integral from 0 to B of R of t dt minus the integral from 2 to B of 5 dt. Okay. So I'm just going to go back to my calculator and do that. If you notice, I still have this stored in from the last video. I have everything in terms of 0 to 8 and 2 to 8. Right? I can just arrow up. I'm going to grab that so I don't have to retype in that whole equation. And I'll just arrow back and change that 8 to a B. Again, we can only use that B if I stored it in my calculator. You can see right here I already did that. So I'm just going to replace that 8 with a B. And do the same thing back here. By the way, I'm anticipating here getting a bigger answer than 89, because I think this is going to be my max, but let's just confirm it. And it is a bigger number, 90.863. Now I know I don't need to check any other times because absolute maxes can only occur at endpoints and critical points. I only had one critical point on that interval, so I know that my absolute maximum value since they wanted the max value, I just report the Y value of 90.863. Be careful because they might have asked you at what time does the tank have the maximum amount of water in it. Then we'd say T equals 7.135, and that would have been our answer. Okay. If you're unsure which one they're asking for, just put both. Okay, the last question I'm going to ask you is this. On 0.8. All right. So I said here, what is the average value of the rate of water filling the tank? What is the average rate of water filling the tank? Okay. And when I have to think here, I have to think, is this average rate of change or is this average value, right? So since the rate of water filling the tank, R of T, is what we have, I want the average of that, okay? So to solve this, I'm going to have to use an integral. I'm going to say, I know the average value formula is 1 over B minus A. Integral from A to B of R of T. Okay. And then I might say include unit. Now, anytime you do an average value equation, right, we have this fraction out front, integral 0 to 8 of R of T dt. Anytime we see this setup, right, the units are going to be in whatever units R of T is in. R of T, I know from the problem, is in liters per hour. So my answer is going to be in liters per hour. And I can just type this in. I can do 1 divided by 8. Math 9. Integral 0 to 8. And instead of typing out that function, I can do alpha trace to use y1 dx. So my average rate of water filling the tank would be 7.452. Again, my units would be the units of R of T, right? All right, they could ask you different questions, but that's kind of a good flavor of a lot of the types of questions they like to ask. Have a good one. 2 chains. Bye.